So today we're going to talk about elimination. This is our third concept when it comes to processes for finding the solution to a system of equations. Personally, this one is probably my favorite. I think it's one of the easiest ones out of the three, or the easiest, I should say, out of the three. So when we do elimination, we line up our equations, and what we mean by line up our equations is we stack our x's, stack our y's, and stack our constants. So we want to rearrange our equations basically so they're in standard form, but they don't have to be like fit all those requirements of standard form. You don't have to have integers, you don't have to have a be positive. You could have fractions, but you probably won't want them. But you just want to stack your x's and your y's and your constants. So if they're not in that order, you put them in that order. Then, if necessary, you would multiply one or both of your equations so that one of your variables has matching coefficients. So, okay, so we want to multiply if necessary so that our coefficients match. So like here, what's the coefficient on x and the coefficient on x? 1. Both of them are 1. Like those ones match, these ones don't, okay? And they can match in the sense that they're the exact same, or this is actually almost better if you have one that's a positive and one that's a negative, because then when you put them together, they're just gonna cancel out, which is exactly what we want to happen. So if they match exactly, you have to subtract one equation from the other. If they're opposites, you have to add the equations together, because we want that variable to go away. And then you'll be left with one variable, solve the equation, plug it back in to finish. So let's look at number 1. We have x plus 7 equals 17 and x minus y equals 7. So we are going to subtract these equations because the variables or the coefficients for x are opposites, or sorry, are exactly the same. So we need to go x minus x for that to cancel out, okay? So the first variable will cancel out, and then the other one, you should have something left over because that's the one we're gonna solve for. If you don't, then that usually is gonna indicate that you have a no solution or infinite solution situation, okay? So if we go to the other one, you just have to be super careful here. When we go to subtract 7y minus negative y, we have a minus here and a minus here. So we end up doing, positive 7 plus y. So this negative, this subtraction has to apply to everything. So it's positive 7 plus y, which would give us 8y. And then on the last one, we have 17 minus negative 7, or 17 plus 7, which is, so that's if you had 17 plus negative 7. If we have 17 plus positive 7, it's 24. And then solve for y. So we divide by 8. And we get that y equals 3. And now, just like when we were doing substitution, we have to plug that back in to get our missing variable that we don't have yet. So I'm going to use the second equation. So x minus 3 equals negative 7. So all I did was substitute my 3 into that second equation, and then we isolate x. So we add 3, we get x equals negative 4. Everybody good there? So that one was pretty simple, especially whenever we start with an equation that has variables that have matching coefficients. That makes it really nice for us to use elimination. Sometimes we aren't quite so lucky, okay? So like, let's go ahead and, if you'll do this one on your own, not yet, but if you were to add these equations, you're gonna, sorry, you can't see that because of the Zoom. If you're gonna add those equations in step 2, that y is gonna cancel out because they're opposites, okay? So that's what you're gonna do on that one. But if we come down here to problem 3, we don't have any matching coefficients. We've got, if we look at our x's, we've got 4 and 1. Those are not opposites, they're not the same. We've got -9 and +5, not opposites, not the same. So we have to make these match. And I always say that this is very similar to making your denominators of a fraction match so that you can add and subtract, okay? So if you can change one of them to match the other one, that's what you should do. But sometimes you have to change both, okay? So the easiest thing to do here would be to multiply that bottom equation by a specially chosen number so that it's going to have a coefficient that matches the top equation, okay? So since we have a 1 and a 5, we can easily make that coefficient of x a 4 by multiplying by 4. Okay, so we're going to multiply that bottom equation by 4. And then I'm going to actually multiply it by -4, because if I multiply it by -4, then they'll be opposites, and I can just add those equations together, and I don't have to worry about the subtraction piece of that, okay? So just to make sure that we are not making any mistakes, I'm going to copy this first equation, 4x minus 9y equals -42. Multiply everything in the bottom equation by -4, so we get -4x minus 20y equals -16. And now all I have to do is add those two equations. So when I add them, what happens to my x's? Or cancel out, because 4x plus -4x goes away. -9y plus -20y is good, -29y, and -42 plus -16 is -58. And then we divide by -29. And we get that y is equal to 2. Now, I'm going to substitute this back in to that equation right there. So y equals 2 goes in for y. So 5 times 2 will give me 10 right there. So x plus 10 equals 4. Subtract 10, and we get x equals -6. And I should have done this on number 1. You want to make sure that you're writing your solution as a coordinate pair. So on number 1, it would be -4, 3. So that's the spot where those lines cross. Okay, so not too bad so far. Which coefficients on number 4 would be the easiest to make them the same number? 7 and 2 or 6 and 3? 6 and 3, and you're going to do that by multiplying the bottom one by 2. Okay, so if you want to write that in, you can come back and do that in a minute. Are you going to multiply by +2 or -2? It really doesn't matter. But if you want to make them opposites, what do you have to multiply by? -2. Okay, and then you'll be able to add them together. All right.
For what number?
For the x's, then if you multiply by -2, you'll have -6 and +6, and then you can just add. And the adding just is easier because then you don't have to worry about like distributing that negative that's on the outside all the way through. It just makes it less likely to make a mistake, I think, if you're doing addition. All right, so let's do one more together. Let's look at number 5 before I turn you loose to work some of those on your own. On number 5, we're already all stacked up, right? X is on top of x's, y is on top of y's, constants on top of constants, which is what we want. None of them match up. I can't multiply 2 by anything to make it a 5, and I can't multiply 3 by anything to make it a 7. So this is one of those situations where it's like when you're trying to add like 1/2 and 1/3, and you need a common denominator. The only option is to change both of them to make them match, okay? So we would multiply both equations by a constant so that the coefficients of one of the variables match up. And there's really no set way that you have to do this. Nothing magical about choosing X or Y to match. It doesn't really matter. Whatever one you pick is fine. So the easiest method to do this would be to pick which variable you're going to match and then just multiply their coefficients by each other. So in other words, we would take the top equation times 2 and the bottom equation times 5, or I'm going to do -5, so that we end up with 10 and -10. Okay? So when we multiply, make sure you rewrite those equations, multiply it all the way through, so we get 10x plus 6y equals -14, and -10x minus 14y equals -15. Now we just add. So what happens when we add our x's? Cancel out. We always want that to happen. Okay, so if you multiply them and nothing cancels out, then you got to go back and pick something else to multiply them by. When
-5 times 7y.
You're right. I multiplied by 2. Thank you. Okay, so this should be -35. Good catch. 6 plus -35 is what? -29y. And -14 plus -15? -29. So then when we go to solve for y, we get 1. All right, now, again, it doesn't matter which equation we put that back in for. Yes, Kayla?
I thought you subtracted.
But you can subtract, or you will subtract if these are the exact same number. But since this is positive and this is negative, the 10 and the -10 are opposites, we add them so that it cancels out.
So you could have multiplied by a +5?
Yep, if I multiplied the bottom by a +5, then I would subtract that bottom equation from the top one. I just prefer to work with the addition if I can. All right, so now we're going to plug that y equals 1 into either equation. Just because it's right there, I'm going to do the bottom equation. So we go 2x plus 7 times 1 is 7 equals 3 minus 7 gives us 2x equals -4. And then divide by 2, and x is -2. So our solution is -2, 1. Okay, so this first page is, I think you guys should be able to do everything on this first page pretty easily. Everything's all lined up for you already. You just have to make your coefficients match. I'm going to give you a couple minutes to work on that one, and then we'll look at the last type, which is where we have to rearrange the problems, and then we'll do a couple application problems, okay? So go ahead and take a minute and solve problems 2, 4, and 6, and then we'll go over those answers. All right, so here is number 2, and you might have set these, well, this one you probably didn't set up differently because you can't see it. This one you probably didn't set up differently because you already had coefficients that were opposites. So all you had to do is add those equations together, which gives you 8x equals 64. So you get x equals 8, and then plug that back in. You get y equals -1. On number 4, you had to make these ones match, and the easiest way to do that, like we said, was to make your y's the same or opposites. So if you multiply the second equation by -2, then all we have to do is add those together, and we get 3x equals -27, and then x equals -9. Plug that back in, and you get -9, -5/3. So even as I was doing this, I was like, okay, where's the answer key? Because why am I getting a fraction? But this one just has a fraction answer in it. And then, as Emma pointed out, on number 46, or sorry, on number 6, it's got a 4 in front. If you make these coefficients match, the x's and the y's both cancel out. And then you get 0 equals -72 or some other number depending on how you made these match. So the point is, one side everything cancels out, and on the other side it doesn't, which means that it's no solution because we get a statement that is never true. Never means no solution. always means infinite solutions. So this is no solution. All right, so let's go ahead and go on to number 7. This is the most complex of the types of elimination problems you'll see, but it's really not that much harder than what we've already done. The only thing different about this one is our variables aren't already stacked for us. So we gotta stack them first, then make them match, then we can eliminate. So all we're gonna do is rearrange this equation, and we're gonna rearrange just the second one so that the x is on the other side under the other x, which is where it should be. So I'm gonna work down this time because I don't like the way my work gets all shuffled around. So 5x minus 6y equals 3 is our top equation. When I shift that 2x to the other side, I get negative 2x plus 7y equals positive 8. To make those equations match, I'm going to multiply my top equation by 2 and my bottom equation by 5, and that will make both of my x's have a coefficient of 10, one positive, one negative. So that will give us 10x minus 12y equals 6, and negative 10x plus 35y equals 40. Add, since these are opposite coefficients, and when we add them together, the x's cancel out, we get 5 minus 2, 23y equals 34. Yeah, 46. I was subtracting. You're right. Do my basic arithmetic today. 46, that would make more sense. Now when we divide, it will come out evenly, and we will get 2 for y. So y is 2. Plug that back in to either equation. I'm going to choose the second one. So 14 equals 2x plus 8. Subtract 8. And divide by 2. And x is 3. How could I check again? We talked about this yesterday. How could I make sure that my solution's correct? Plug it in, make sure it works in both equations. Okay? All right, so you'll be able to do number 8 here after we look at an application problem. But these application problems are sort of like what we did in the last chapter, or in the last section of chapter 1. But they're a little bit simpler, I think. You're going to set up 2 equations, though, instead of 1 on these ones. But they're going to be using the same 2 variables, and we're setting it up so that elimination works, okay? So first step is to define your variables. Second step is to set up your 2 equations, just like we did in the last chapter, and then solve the system. And you could use elimination, you could use substitution, you could use graphing, but probably you're gonna end up using substitution or elimination here. So Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If books cost $1.50 and CDs cost $5 each, how many of each did she buy? So we can set up 2 equations here because we're talking about books and CDs, right? So B will be the number of books that she bought, and C is going to be the number of CDs that she bought. So if we take the number of books and the number of CDs that she bought, all together, she got how many total items? 20. So just taking B plus C will give us 20. That's our first equation. So usually one of your equations is going to be really simple, okay? Now, not only can we relate these 2 things together because we know how many she bought, but we also know how much money she spent. So that's going to be our other equation. It's going to deal with the money part of that, okay? So the money aspect of this, I really hope that's recording, is that she bought the books for $1.50. So to figure out how much money she spent on books, we do 150 times B. And she bought, you're right, Ash, you're tired. She bought CDs for $5. So 5 times the number of CDs will give us how much she spent on books plus how much she spent on CDs is going to tell us how much she spent altogether, which was how much? 50 for 50, right? So we've got our 2 equations. If we want to use, so we could use substitution, okay? We could isolate B or C in that top equation and then substitute it in, or you could use elimination. Let's use elimination on this one. So to make these match, I'm going to multiply that top equation by, I'm going to do -5 and then put it down below. So I'm going to go, just make sure you line these up correctly, okay? So -5B, make sure you don't take that away from the 50 cents, take away from the 1, minus 5C equals -100. So when I combine these two, we get -3.5B equals.
Wait, I thought you were multiplying by -5. The one that's -5.
I multiplied this equation by -5. So -5 times B is -5B. -5 times C is -5C. And then -5 times 20 is -100. Does that make sense?
Yeah.
So then now I'm adding the 2 equations together. Is the step that I'm on now. So if I add these 2, I get -3.5B. If I add these 2, it goes away. And if I add these 2, I get 45.50. 45.5. So then and that's a negative, right? Because the 100 was negative. Divide by 3.5, so you might want to grab your calculator for that one. -45.5 divided by 3.5. Tells us B is equal to what? 13. Which means if she bought 13 books and 20 items altogether, how many CDs did she get? 7. Okay, so 13 books and 7 CDs. And I didn't write that because that was pretty simple using that top equation. But you could always write it. Okay, so I want you to have a couple of chances to practice application before you do the homework on your own. So I'm not going to do the other 2 application questions. I'm going to let you guys do those for practice. So go ahead and work on that, and then we will go over those answers. Just in case it doesn't work. That's okay. A lot of people focus on the applications. But on number 8, you have to rearrange and put them in order. So this up here, they move the 9x and actually they're moving the 5y to this side and the 4 to the other side so that we can stack the x's and the y's, and they actually switch these 2 values as well, okay? So you wouldn't have to do all that. You really could solve this by leaving the x and the 18 and then just flip-flopping your 9 and your 4, and it would be just fine to do that. But we really have a tendency to put them so that there's something times x plus something times y equals the number, and putting them pretty much in standard form when we use elimination. So rearranging all of that, when you flip-flop what side everything's on, the 8y becomes positive, the 18's negative, the 5y's negative, and the 4 is positive. Or sorry, negative. So then we can multiply so that our coefficients match. And this, on the way this one was done, they made the y coefficients opposites. So multiplying the top by 5 and the bottom by 8 gives us 40y and -40y. When we add together there, we get 122x equals -122, which means x is -1. And then plug that back into that top equation, and we get 8 equals negative 8y, so y is also negative 1. So negative 1, negative 1. Lots of big numbers in that problem for something that turns out to be a nice, small, simple answer. Okay, so looking at 10 and 11, and I know this is where most of you spent most of your time. Number 10, we're calculating how much money Landon makes per hour at each job. So as you are setting up these problems, if you're really struggling with defining your variables and knowing what to set your letters up to be, read that last sentence. If they want to know how much does Landon make per hour at each job, that's what my variables need to represent. So again, I'm not super fond of the way they label these all the time. B would not be just babysits. It would be the hourly wage while he's babysitting, and the water park hourly wage. Or you could say like dollars per hour babysitting, dollars per hour working at the water park. Then we set up 2 equations. So this one right here is our equation for week 1, and this one right here is our equation for week 2. My timer's going off, so I'm gonna have you guys switch mask breaks. Non-green tape, you guys can go for 10 minutes here. So 3 hours babysitting, 10 hours at the water park, he makes $109. On the second equation, we have 8 hours babysitting, 12 hours at the water park, he makes $177. Then multiply to make our coefficients match. We're multiplying by 8 and negative 3 so that these ones right here will be opposites, which gives us 24 and negative 24, which cancels out. 80 plus negative 36W equals 44W. Those big numbers we ended up with on the end give us 341. When you divide, you get 7.75, and because we're looking at an hourly wage, that makes perfect sense. That's $7.75 per hour at the water park. Plug that back into one of your earlier equations, and we get $10.50 per hour babysitting. Okay? And then this last one was a little bit different because it's more like our problems at the top of this page in regards to how the equations look. Kent has a collection of pennies and nickels with a value of $1.98. The pennies, the number of pennies he has is 5 less than twice the number of nickels. Right here, this is telling us what we want to set our variables equal to. How many of each coin does he have? So P is going to represent our number of pennies, and N is going to represent the number of nickels. Sometimes they're really nice and they just say, he's got 42 coins altogether. So then you just say N plus P equals 42. On this one, they weren't quite that nice. So let's start with the first equation because that's probably a little bit easier. We know they have a total value of $1.98. Remember, if we're adding the value of our nickels and our pennies, we have to incorporate the value of a nickel and the value of a penny. This is like our hourly wage problems that we were just doing to find his total amount of money. You can't just add the number of hours he works at both jobs. And you can't just add the number of coins he has. You have to multiply them by their individual values. So 0.01 times the number of pennies, so 1 cent per penny will give us the number of cents that he has in pennies, and 0.05 times the number of nickels will tell us how much money he has in his nickels. We add those together to get his total amount of money, which is $1.98. All right, then the next question, or the next equation comes from the number of pennies he has is 5 less than twice the number of nickels. You always want to look for the word is in these problems. If it's in there, that's where your equal sign is. So the first part of the statement, the number of pennies, that's P, is, that's your equal sign. 5 less than twice the number of nickels is 2n minus 5. 5 less than twice the number of nickels, which is n. Okay, so P equals 2n minus 5. That's our second equation, which doesn't line up right now with what we have, but we can make it line up if we rearrange it. They multiplied everything by, they actually didn't use elimination here. They used substitution, which is ideal since we have a variable isolated. So if we take and we plug 2n minus 1 in place of p, I know that's kind of throwing it back to yesterday, so you have to remember what we were working on yesterday. 0.01 times p, which becomes 2n minus 5. So we just replace this for p, plus 0.05n equals $1.98, and then you just multiply through and solve for n. We end up with 29 nickels, or 29 nickels and 53 pennies when you finish solving that whole problem, okay? So on these application questions, sometimes they're gonna be set up like this, where it makes sense to use elimination, and sometimes they're gonna be set up like this, or your equations will turn out like this, where it makes a little bit more sense to use substitution, okay? So you can pick and choose as you work through your application questions. There's a whole nother page of application questions. We're not gonna do that one. You're welcome. So the only thing that you guys have for homework then is on the homework page, you have 8 elimination problems and 4 application questions. And these application questions, they are really good because, I mean, when kids say, when are we ever gonna use this? Why do we have to learn this? These are the things that applications are exactly what that's for. It's real world problems that use the concepts that we're learning. So, all right, so that's what you have for homework is homework, I think it's homework 5. It should be the next page at the back of your packet for homework. Yep. Oh, come on.